Hey there, class. Mr. Plosky here. Hope you're having a good day so far. This is a new chapter for geometry. This is chapter 11, and today we're talking about, and in this chapter we're talking about area and different kind of measures of two-dimensional shapes, and then in chapter 12 we'll probably talk about, like three-dimensional shapes like volume and stuff. So, and even surface area too, okay? So today is 11.1. It is area of triangles and parallelograms. Our essential question is how do we find areas of triangles and parallelograms? All right, let's get into this here. So the basis of a parallelogram. What's a parallelogram, by the way? See if you can pause the video and just kind of think about what's the definition of a parallelogram from a different chapter. Go ahead. All right, so a parallelogram, if you recall, this is just kind of a generic shape. This is not great. I can't draw really straight lines on this app, but that's okay. Do the best I can. Okay, so this is kind of a parallelogram, which means the definition of a parallelogram is a quadrilateral with opposite sides that are parallel. All right, so we're going to talk about definitions. The basis of a parallelogram are either pair of parallel sides of what? Parallel sides of a parallelogram. Okay, so for example, these are going to be the bases. These are bases here, okay, the sides, all right? The height of a parallelogram is going to be the perpendicular distance, the what? Perpendicular distance between the bases of a parallelogram. So, normally it's kind of drawn in the middle here like this. This is a height, okay? Or you could actually have a height outside of a shape like this. This could be a height as well because it's still at a right angle. As long as it goes straight down at a right angle to the other side, if you extend the side a little bit further, they can still be the height, okay? And that's kind of important for like, triangles that are obtuse, where the height from one vertex is going to be outside the triangle, okay? All right, we have some postulates here. Let's get into these. All right, area of a square. What was the area of a square? Well, let's draw a square here and see if you can figure it out, right? So a square, the main part of a square is that all the sides are the same, right? So it's the side, and side. These are all sides, they're all S. What's the area of a square going to be, right? Well, the area of a rectangle, which we learned about a while ago, was length times width. What's the area of a square? Well, it's going to be side times side, or side squared, okay? The area of a square is the square, which means this little square, 2 here, right? The square of the length of its side. That's the area of a square. Very cool. All right, area congruence postulate. 2 polygons are congruent if they have the same area. If 2 polygons are congruent, then they have the same area. There are ways to have polygons that are not congruent that have the same area. That was a mistake, I apologize. But if 2 polygons are congruent, then their areas are the same. That's what I was saying. It's not what I was saying. All right? All right, area addition postulate. The area of a region is the what? Sum of the areas of its non-overlapping parts. So I'm going to draw kind of a weird shape here. I'm going to draw this, okay? So here's a weird kind of shape. What 2 shapes kind of look like they make up this shape here? Well, you can go either a couple different ways. If I do this, right? If I do this, I could call this part A and this part B. So basically, the area equals the, that's not going to work. Let's call it X and Y, actually. Let's see here, give it a second. Yeah, we'll call it X and Y. So you're not going to see what I just wrote here, because I'm erasing it. So we have X and Y, right? The area is going to equal, instead of figuring out the area of a weird looking shape, we can break it into shapes that we know already. Like we could say X is a rectangle, Y is a rectangle, and then add those together. So it's going to be X plus Y, okay? So that's the area addition postulate. All right, area of a rectangle, we talked about a little bit here. A rectangle is like this. We have length and width. Area equals what? Length times width. So it's product of its length and width. Very cool. Area of a parallelogram is very similar. It's very similar to actually a rectangle is a type of parallelogram. But if we have parallelograms that are not rectangles, we have a little bit of a different thing here. So if we have a parallelogram, again, let me try to draw this. Okay. It's going to equal, not length times width, but base times height, okay? So it's going to be, remember the height was, this is the height at a right angle, and then the base could be like this right here. That's the base. Any of those sides there, okay? Well, the side that's going to be perpendicular to the height is going to be a base, okay? But also you can see here, the width is kind of the height, right? And the length is kind of the base. So it's just kind of a variation of that. So area of a parallelogram is based on the product of a base and its corresponding height. So it's basically like a rectangle that's kind of pushed over a little bit, right? That's going to be a parallelogram. Area of a triangle. You guys remember the area of a triangle? So here's a triangle here, right? Oops. Let's go over here. I'm going to go kind of off the page a little bit even. Okay, here's our triangle, right? What's the formula for area of a triangle? Well, it's going to be 1/2 base times height, or base times height over 2, right? So here's the height. Here's the base, okay? Now, why is that? Just for fun, let me show you something here, okay? So here's a parallelogram, right? So the formula for a parallelogram was what? It was base times height. Now watch this. If I split this down the middle, what two shapes do I have here? I have two triangles, right? So basically, this is 1/2 of a parallelogram, and this is 1/2 of a parallelogram. And the parallelogram equals, or sorry, yeah, parallelogram was base times height, so it's base times height over 2. That's kind of where it comes from, okay? Very cool. So like in here, we filled out this. The area of a triangle. Let me zoom out so you guys can see that. Area of a triangle is 1/2 the product of a base and its corresponding height. All right, very cool. Cool, let's get into a problem here. So it says find the area of the parallelogram. Why don't you guys pause the video and see how you do here. All right, so what's the formula for area of a parallelogram? It's base times height. So we need to find base and height. What's the base of this parallelogram? Well, the base is going to be, let's see here. So I would say this is actually not a height right here, guys. This is not a height because it's at it has to be perpendicular to another base, right? This is at kind of a corner. I guess it could be, actually that could be a height if you knew this length right here, but it's actually, we don't know that, right? So in this case, the base we're going to use is 9. And I try to throw you off here with all these different things here. And the height's going to equal what? So here's the base, right? Now what's the height? Height's going to be 4. So what's the area going to be? Base times height is 9 times 4, which equals 36. All right, sounds good. All right, we got some checkpoints here. Why don't you guys go ahead and see if you can find the area of these shapes. All right, what shape do we have for number 1? Looks like a triangle. All right, so we need, what's the area of a triangle going to be? It equals base times height over 2. So we need to find the base and the height. What's the base of this triangle? That's a little interesting. This is the height, right? Because it's at a right angle here. So we know the height is going to be 28. What's the base going to be? It's not just 45. It's not just 21. It's going to be 45 plus 21, which equals 66. All right. So now we just plug it in. So we have area equals 66 times 28 over 2. So that's going to equal, what, 528 over 2? Which equals 264. And that's going to be the area. All right, sounds good. How about number 2? What kind of shape is that? That's a parallelogram. So area equals base times height. What's the base? Base is going to be 17. What's the height? It's going to be 7. So we do area equals 17 times 7, which is 119. Area equals 119. Awesome. Okay. Now, this example's okay, I guess. So now what we're doing is we're solving for unknown measures. We talked about this a little while ago, but let's get into this here. It says the base of a triangle is 4 times its height, and we know the area of the triangle is 50 square inches. We're finding the base and the height. Okay. So we actually don't know everything here, but that's okay. So let's just draw a triangle first, or attempt to. Okay, here's the triangle, right? We know the height. The base is 4 times the height, right? So the height, let's call the height x, right? Whatever you're using to compare other things, you want to call that the thing, right? What are we going to call the base? The base is going to equal 4x, right? Because it's 4 times the height. So now we can just go ahead and we can solve this. What's the area of a triangle here? So the height equals x, the base equals 4x, and we also know the area equals 50, okay? I want you guys, now that we know this, I want you guys to see if you can pause it and figure out what this is going to be. Solve for the height and the base. All right, area of a triangle is base times height over 2. So the base is, we had 4x times x. Oh, and actually we know the area too, my bad. So the area was 50, so 50 equals 4x times x over 2, okay? We have to solve for x now. I'd like to multiply by 2 on both sides. We get 100 equals 4x squared, 4x times x. Now solve for x, we got to divide by 4. We get 25 equals x squared. How do you get rid of a square? Got a square root. So we get 5 equals x. It would be plus or minus, but we're not going to have a negative distance. So we know the height, which is x, is 5. The base is 4 times x, right? 4 times 5 equals what? Equals 20. It's going to be inches. 20 inches and 20, or 5 inches and 20 inches. All right, why don't you guys go ahead and try to checkpoint 1, which is a little bit easier. Give it a try. All right, parallelogram has an area. Area equals 133 square feet. We know the height is 19. We're looking for the base. So what's the formula for area of a parallelogram? It's base times height. So the area is 133 equals, I guess, base times 19. Go ahead and pause and solve if you're able to. Divide by 19. So the base is going to equal 7 feet. Awesome. All right, last problem we're going to do here. We're not going to do checkpoint 4. So we're vacuuming a living room and we'd like to know how much area you have to cover. You know, as you do when you're vacuuming, you want to know exactly, you know, what that's, yeah, whatever, that's fine. So here's what we're going to do. We have this weird shape here. Can you guys see, can we draw any lines anywhere to like make these, this is not really a shape that we know like a formula for. Is there a way that we can like make this a little bit easier? What if I draw a line right here, right? So this is 9. This is 5, and this is 4, right? And so that what 2 shapes do we have here? Well, this is, I'm going to call this y right here, right? And call this x. So can we see what kind of shapes we have here? Well, yeah, so basically that formula we learned before is that area is going to equal x plus y, right? So, so x is what shape? That's a rectangle. And y is what shape? It's a square. So basically, we're going to find the areas of each of those, and then we're going to, then we can add them together. I want you guys to see if you can figure this out on your own. Go ahead. So, area of a rectangle is what? Length times width. And what's the area of a square? It's the side length squared. So, we have to find the, what's the length of the rectangle? How long is the rectangle? It's 9. What's the width of the rectangle? 4. And what's the side of the square? It's 5 squared. So 9 times 4 is 36. 5 squared is 25. 36 plus 25 is going to be 61 meters squared. All right, and that is going to be basically, yeah, so it's basically 61 meters squared by adding those 2 weird shapes. Another thing we could have done is we could have like added this. We could have like just done like a, this is basically a 9 by 9 square, right? This whole thing is a 9 by 9 square. We could have subtracted like this section here to figure out the rest of it too, if you want to think about it in that way. All right, we're not going to do checkpoint 4. That's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.